All right, this is video 2, Geometry Honors. We just got done talking Monday and Tuesday about Pythagorean triples and classifying triangles as either right, acute, or obtuse based on whether or not Pythagorean theorem works for them. Today we're going to talk about a different kind of special right triangles. So we're going to jump right in. We're talking about special right triangles based on their angles. So we're going to talk about two specific ones today. Okay, and those are, okay, a 45, 45, 90 triangle. So 45, 45, 90. If you can't see that, move your little eyes closer. Sorry. That's 45 degrees, and 90 degrees. Okay, we'll write this 45, 45, 90. Okay, also the other one would be a 30, 60, 90. This is one that you will need when you get to Algebra 2, a 30, 60, 90 triangle. 30, 60, 90. Notice these are triangles, so if we were to add those three angles up, guess what they add up to? They add up to 180. Surprise, right? They should. All triangles should add up to 180 on their angles. Sure enough, when I add 30, 60, 90, when I add 45, 45, 90, they add up to 180. Hooray! All right. Now, why are these special? Well, they're special because they've got some relationships with how every single time we can find missing sides, because they have a relationship between the sides, okay, that's always the same. Okay? Let's start with the 45, 45, 90. Okay? For example, okay, if I said this is a 45, 45, 90, that's a terrible drawing of a 45, 45, 90. I've been sitting at home eating Cheetos for 3 weeks, so I'm out of practice on drawing triangles. Just kidding, I don't really like Cheetos. But anyways, so I got a 45, 45, 90. Okay? By the way, this is the last video I'm making for the day, so you can tell I'm ready to be done, but it's okay. We'll get there. All right, so 45, 45, 90. Okay, here's the special relationship. First of all, we know that the 45-degree angle and the 45-degree angle, those sides are the same. We learned this earlier this year when we talked about isosceles triangles theorem, right? We said if I know two angles are the same in a triangle, that means it's an isosceles triangle, and their corresponding or their opposite sides have to be the same as well. So since these are the same, I know these are the same. So we're going to say this one is x, and because they're the same, this one has to be x. Okay? It doesn't have to be x. It could be a number. Okay? If we knew one of the sides was 2, the other side would have to be 2. One of them was 17. The other one would have to be 17. Even if it was a decimal or a radical or something. If one was square root of 6, the other one would be square root of 6. Okay? They're always going to be the same. The relationship here, though, is okay, the third side, the hypotenuse, is always going to be that small side multiplied by square root of 2. Okay? In this case, because the small sides were x, this is x square root of 2. Okay? X times square root of 2. Okay? Now, let's show how this works with Pythagorean theorem. Because if this is truly a right triangle, Pythagorean theorem should work. So small side was x squared, plus small side was x squared, equals big side, x squared root of 2 squared. Does that in fact work? Well, x squared plus x squared. This is like 1x squared plus 1x squared. So that's 2x squared. And remember, like we just said on Monday, or in the first video, when I've got this, it's like I'm distributing. X squared is just x squared. Square root of 2 squared, well, it cancels. And this just gives me 2, right? So what is 2 times x squared? It's just 2x squared. So does 2x squared equals 2x squared? Yes, it does. That is a right triangle. Going back to what we talked about at the beginning of the week. If it works, it's a right triangle. Okay? So the short sides will always be the same in a 45, 45, 90. The long side is the short side times square root of 2. Okay? We'll see what that looks like in a minute. In a 30, 60, 90, notice these are not the same, so of course their sides will not be the same. However, there is still a key relationship. Let me draw this a little bit of a different way. Let's say this is the 30, this is the 60, and this is the 90. All right? The short side we're going to call x. So let's say, across from the 30, that's my short side. We're going to say that's x. Well, the relationship between the short side and the hypotenuse is it's always twice. So if the short side is x, the long side would have to be double that, 2x. If this short side was 4, the long side would be 8. If the short side was 7, the long side would be 14. If the short side was 2.3, the long side would be double, 4.6. Okay, you're just taking the short side and doubling it. Okay, now the medium side, the part with the square root, with the 60-degree angle, is the short side. The relationship there, the short side times square root of 3. The short side times square root of 3. So no matter what it is, if the short side is x, it's x times square root of 3. If the short side is 5, it's 5 times square root of 3. If the short side is square root of 7, it's square root of 7 times square root of 3. Square root of 21, right? With that said, okay, let's see if this works with Pythagorean. Okay, short side, x squared. Medium side, x square root of 3 squared. Long side, 2x squared. Okay, remember, if this truly is a special right triangle, and it is right, okay, this should work. Okay, so x squared is just x squared. X squared is x squared. Square root of 3 squared, remember those cancel, and that's just 3. Okay, 2 squared is 4. X squared is x squared, so 4x squared. Well, here this is x squared. X squared times 3 is 3x squared. And this is 4x squared. Well, what is x squared plus 3x squared? It's 4x squared. So 4x squared equals 4x squared. Does that work? Of course it does. Okay, so because this works, it is a right triangle. Okay, it's special. All right, it's a 30, 60, 90. Short side is whatever it is. Long side is that side multiplied by 2. Medium side is that side multiplied by square root of 3. Don't forget though, we can always go backwards with this. It's not so robotic, it has to be the exact same way. We can go backwards. If I know the long side, this should be half of the long side, right? If I can multiply by 2 to find the long side, I can divide by 2 to find the short side. Okay? If I can multiply by square root of 3 to find the medium side, I can divide by square root of 3 to find the short side. Okay? So let's take a look at a few examples of this and how we can use it. All right? Yeah, so let's look at a few examples here. All right? Don't forget, as we're going through these examples, if you've got any issues, you can email me, get a hold of me in some way, shape, or form, or log into the old Google Meet Wednesday, Thursday for this one, and ask any questions that you have. So let's say I've got a right triangle. Okay, they tell me that one angle is 45. Okay, and I've got A, 3, and C. Okay, I'm looking to find what is A and what is C. Well, I know this is a special right triangle because I know I've got 90, I've got 45, the other one has to be 45. Okay, and once I know that, those are both 45, and this is a special 45, 45, 90 right triangle, then immediately I know, okay, that the two short sides are the same. Isosceles triangles theorem. Short side and short side, these are the same. If the angles are the same, the sides have to be the same. So immediately, A has to equal 3. Okay? And then C, in 45, 45, 90, C has to be the short side multiplied by square root of 2. So C would have to be the short side 3 times square root of 2. There's nothing I can do to simplify that. So it's just 3 times square root of 2. Done. Easy, right? Not too big a deal. Let's look at another example. Okay, let's say they tell me this is 45, this is 90. Okay, I know this side is x, and this side is 10. And I'm asked to figure out what is x. Well, like I just mentioned a few minutes ago, this is the opposite. Okay, since these are the same, they're both x, we said I could take x and multiply it by square root of 2 to get this. Well, I've already got this, so if I want to find x, I can work backwards by dividing by square root of 2. So if I'm looking for x, x is going to be this 10 part, the hypotenuse. Working backwards, I'm going to divide by square root of 2 in order to find x. Divide by square root of 2. Now that would be an okay answer, but as you'll see in Honors Algebra 2, and we've talked a little bit about this year, we're going to want to rationalize the denominator. In other words, get rid of square roots in the denominator. The way we will do that is multiply by whatever's in this multiply by the root in the denominator. So I'm going to multiply both the top and the bottom by square root of 2. Okay? On the top, 10 times square root of 2 would be 10 square root of 2. On the bottom, square root of 2 times square root of 2 is just 2. Okay, it's like square root of 2 twice. In other words, square root of 2 squared, right? And square root of 2 squared would be, like canceling, it's just 2. Or you could say square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Either way you want to look at that. Then we can reduce. 10 divided by 2 is just 5. So my answer is 5 square root of 2. Okay? So in this case, x would be 5 square root of 2. Just like over here, we said we could take the short side and multiply by square root of 2 to get the long side. Here we can take the long side and divide by square root of 2 to get the short side. Okay? Let's look at what we do if we've got a 30, 60, 90 triangle. Okay? Yada-dee. Flip the page. All right. So let's say I've got a 30, 60, 90 triangle. We'll do 2 of these, and then we'll be donezo, right? So I've got this, let's say this is 60, this is the 30, and they've told me this is A, almost like the same thing, A, B, and 10, right? A, B, and 10. Okay, this isn't too bad, right? Okay, so if I'm looking at this, I know my short side is always multiplied by 2 to get the long side, or the short side is half of the long side. So if I know the long side is 10, the short side B would have to equal 5 immediately. Okay? Short side 5 times 2 should give me 10. Or long side divided by 2 should give me short side 5. That works, right? And then A is pretty easy then, because the short side, 5, multiplied by square root of 3 should give me A, right? So 5 is the short side, because it's half of 10. Multiplied by square root of 3 should give me A, 5 square root of 3. Done. Easy peasy. Lemon squeezy. Okay? All right? Then, one more example. Okay? Let's say I've got yada-dee, 30, 60, 90. Okay, remember the one across from 30 is always going to be my short side. Let's say this is B, this is A, and this is 8 square root of 3 this time. What do I do here? Right? So in this case, again, it's almost like this, only now instead of just a whole number, which I can easily take in half, I've got a radical. No big deal, right? So I'm looking for the short side. The short side is B. So B is going to be half of this. Well, it's almost like just taking this and dividing by 2. Well, what is 8 divided by 2? This is like I have 8 square root of 3's. Well, what's half of that? It would be 4 square root of 3. Okay? 4 square root of 3. That's not too bad, right? 8 square root of 3 divided by 2 would be 4 square root of 3. Then, if I want to find A, the other side, if this is 4 square root of 3, it's almost like that times another square root of 3. So 4 square root of 3 is the short side times square root of 3. Well, how do I do that? Well, we said we multiply the whole numbers out front. 4 times 1 is just 4. Square root of 3 times square root of 3 is square root of 9, which is 3. So A is going to be 4 times 3, which is 12. So short side, 4 square root of 3, because it's half of the hypotenuse. Okay? Medium side is 12, because it is the short side, 4 square root of 3, multiplied by another square root of 3. Okay? 4 times 3, 12. Okay? On your work for Wednesday, Thursday, you're going to be taking these 30, 60, 90s, and you're going to be finding missing sides using the exact same process we just did on these 4 examples. All right? Again, if you have any questions, log in Wednesday, Thursday, ask them. I would love to see all of your smiling faces. Miss you all. Have a great day.